Why don't supermarkets use ammonia? I guess initially fear of the unknown. I'm kind of excited that that may change in the very near future. I'd like to think that they would take up that challenge and move into it. But I guess it's always fear. It's fear. We did a little supermarket. We did a SPC, Factory Sales, a famous entity in Shepparton, SPC. We did an ammonia plant, low-temp ammonia plant in that facility, and it was the first low-charge DX ammonia system I think that ever had been tried in Australia. For us, it was an unfortunate and dismal failure. Not so much from the fact that the system didn't work. It worked particularly well, but I didn't pay enough attention to the detail, and in that the the hot gas defrost system that we used didn't work particularly well. But the biggest failure was our compressors. The compressors, the small reciprocating machines that we used at the time, didn't. They just used oil. They just drank oil, and the oil was in low temp DX. Oil is the enemy. And we just didn't have. We just ran out of money to pour into R&D in the field. We just couldn't sustain it, so we had to pull it out and convert it back to a Freon system purely for cost-saving measures. Sorry. The critical point though was that we had we didn't have a big leak. We had a little leak in the system. Now I could almost guarantee you that that was in the freezer, and I'd left a gland undone, and it was quite pungent. In fact, it was eye-watering pungent. We closed the doors in the freezer, and I said, just put doors up, do not open. And I will guarantee you, had the fire brigade been called, the whole block would have been isolated. We would have had media. It would have shut down the complex. And this is a scenario that the supermarkets would fear, I think, Stefan. You get that situation where there's liability, there's a major complex, and you've got a situation like that occurring. They're in big trouble. I think you'd verify that, Michael, would you? Yeah, it's something you wouldn't want to have happen in a store.
We've got our corporate responsibilities, and like you said, we're looking at these initiatives. And I think that what we'll, display at the ARB show and the Atmosphere show will steer that we're taking those steps to move forward to, natural solutions.
I've worked with ammonia since 1959, and the only thing it's done for me is stunt my growth. And it's supposed to be a fertilizer. But having said that, I had one bad experience myself on a ship when I did up an oil drain on a seawater cooled condenser, and the valve came out and the ammonia. Luckily I had a gas mask on, and when there was an ammonia smell, the engineer on duty closed the watertight doors and started a water spray to absorb the ammonia. And I could only get his attention by knocking on the wall with a big spanner in the rhythm of the engine. So he started to look, excuse me, still get excited about it. But so I got out and no harm done, except that the provisions got a little hot and some of the cargo suffered a bit. But the most insidious experience I had, and that's what I would like to say, is the personal experience again with R22. We were loading tea in Colombo on the ship, and I heard the duty engineer rattle Freon bottles. And when I went 6 in the morning, when I went down, I said, "What are you doing?" He said, "Well, I got no R22 in the side glass." I said, "Well, where is it?" He said, "Well, I don't know." I said, "But before putting any more Freon on, let's find out where it is." Anyway, I went forward and found R22 spitting out of a joint at the TX valve. And I got a little dizzy standing there, and I said, "Oh, well, I probably drank a few more beers last night than I should have." So I went up on deck, climbed the steep ladder, and I collapsed there. And the difference is, with some CO2, I knew exactly, or it was R22, I knew exactly what was going on. It was ammonia. The R22 was sneaking up on me. And when I got dizzy, I ascribed it to an excess amount of alcohol, otherwise I would have been dead. And that's very insidious. And from what I can gather, there have been many more times deaths due to suffocation in confined spaces with chemical refrigerants than there have ever been with ammonia.
And we don't have the data, and it's not reported.
No, but no, absolutely. But there is a fellow that did a lot of work on that, Anders Lindborg. Unfortunately, he died. But Anders has got some good information on that. I think we can make available. Thank you.
Yeah, there is a supermarket in Sydney with a CO2 cascade to ammonia. It's out at St Mary's Way. It's been running for 5, 6, maybe 7 years. Yeah, Ropes Crossing. It runs all right. It had lots of dramas at the beginning because things weren't done the way they might have been done. But once they got over the initial hurdles, the thing just runs along. No one knows it's ammonia on the roof. Has a lot more gas than it needed to have, but you know, technology's changed and it could be done better now.
I just want to be clear. My impression is in the commercial refrigeration space, and for that matter in the split space, that we're scratching the surface. Are we scratching the surface or are we kind of rubbing it? And there's this huge amount of work to do to increase efficiency and reduce emissions. Is that right?
Well, from our side, is that everybody's out there trying to sell in the split side a new installation and competing over price. But we sit and think there must be about 14 million old R22 systems that are out there and they need to be replaced. They're by far the largest market share. I just don't know why you guys are so damn blind.
Look, the biggest issue is training. If you looked at the small contractors who make up the majority of the refrigeration work done, say, in Sydney, very few of them would be prepared to take on a hydrocarbon job or a CO2 job because they simply haven't had the experience and they haven't had the training. TAFE don't cover it in their standard training, to my knowledge. There's a really good facility out at, what's it called, Ray? Narimba. Transcritical system, subcritical system, ammonia system, all sitting there, and it's a ghost town because no one's pushing people out there to do the training. TAFE is ready to do it, but the industry's not asking for it. It's an issue.
So, well, you can have your say in a minute, Ian. I just want to make this point. While I agree there's an immense training requirement, the real problem is lack of demand for natural refrigerant-based solutions, which are driven by a consulting industry that is not well informed about the value of natural refrigerants. Maybe, Ian Tweena, you'd like to comment on that.
Can I say something? In my side, in the split system air conditioning, I don't think it's a lack of training. It's a lack of balls. The truth of the matter is that, and I explain this to people all the time, and the world of academia suffers from this. I honestly believe that's why you get us refrigeration mechanics to do it, and the rest of you guys talk about it, is that you can read 300 books on how to ride a push bike. At the end of the 300th book, you still don't know how to ride a push bike. Is that this industry just needs more people that are willing to go out there. It's not that dangerous working with a hydrocarbon than what it was working with R22. As you could see from Selwyn's slide earlier, the auto ignition temperature for most of the oil is 270 degrees. Is that we have a situation, I believe, in Melbourne where a young man was burnt badly. And they're saying now, oh, it was the oil mist. Well, it was always the oil mist that was going to burn you. You know, so we're all quite well trained. We just need to do it.
It's interesting. You look, I mean, I was critical of the consulting industry with the Bangarang project. Also, the Melbourne wholesale fruit and vegetable market is another classic example, a brand new facility that went in, just completed, state of the art, and I would have said state of the art. It's already obsolete. And there's a whole mixture of reasons for that. It's the risk adverseness of perhaps the consulting industry. It's safe, and they don't want to stick their neck on the chopping block. Generally, the contractor is the one who finishes up wearing the responsibility at the end of the day. But that there's two classic examples there where and I just kind of encourage the industry to be forward thinking rather than retro thinking. We've reached the point, we're at the precipice. We have to make the change. It's clear that Europe is doing it. We just need to think a little bit more with a wider perspective and a different paradigm. And we can engineer 90% of the problems out of the equation. We used stainless steel tube. I know Stefan's using stainless steel tube. We're trying to keep the costs and those sorts of things on ammonia plants down by utilising that. When I started my apprenticeship, they were vertical twins, open-glanded compressors, and that was the norm, It's far from that now. It's far from that now. And the equipment that's now available, we need to rethink. There is the gear out there. It's difficult to get some of it in Australia. Certainly when we went into the transcritical side of things, with the Exquisine project, that was our biggest problem. Everybody said, all the wholesalers said, we are CO2 ready. Well, they were far from being CO2 ready. We simply couldn't get the equipment here.
I'm Lyle D'Souza. I'm from Legal Energy Lawyers and Engineers. I'd just like to thank you all for your presentations. It was very inspirational and an eye-opener. But in terms of ambition, you're talking about ambition of the sector. One question that comes to my mind is why in Europe and Japan and other countries we have district-scale heating and cooling. Why aren't we talking about that more here in Australia for property developments when we're just talking about supermarkets, shopping centres and so on?
Well, that's a very interesting question, and the basic reason is, I think in Australia, that we need a lot of cooling and very little heating. And it is difficult to be looking at a large project in Victoria at the moment to revitalise the Alcoa smelters power station and convert it to a waste burning station. The waste that normally goes into landfills. The real problem is how to get rid of the waste heat. The electricity we'll generate can go into the grid as green power, but then we got some 70 or 65% of the heat left. And what are we going to do with it? Because we don't need that much heat. So we are now looking at perhaps huge CO2 two-stage heat pumps to desalinate seawater to get some use out of that heat. Now, in other countries like Europe, America, the heating cooling balance is much greater, and indeed a lot of modern buildings, it's a perfect situation in that a lot of modern buildings require cooling even in cold weather. So you get the zonal requirements for heat, and in the same building you get the zonal requirements for cooling. That's a perfect match. Doesn't exist so much here in Australia. But I go almost every year, to the District Heating and Cooling Convention in Asia, and that is the same problem. But North China, we're looking at the 21 square kilometre heating and cooling job, and it's perfect around Harbin, That's where all the ice statues are annually. So I think that's the explanation.
My name is Andy Isold, and I work for a manufacturing company called EVAPCO. I too want to thank everybody for your great presentations this morning. They were very informative. My question is for Ian Wilson. In Klaus' presentation, you had a pretty strong argument for using evaporative condensers in CO2 applications, and in the three examples I saw from you, I think you used mostly dry coolers and maybe adiabatic condensers. I was just wondering why you selected those rather than an evaporative condenser.
The really simple answer to that is it's almost impossible to buy an evaporative condenser specifically designed for CO2. As Klaus will tell you, he's done a lot of work on it, and technically there's all sorts of issues, shall we say, to get the thing to work right. I know Klaus is well down the track of developing one. I'm probably 99% of the way towards developing one, to be honest. But yeah, you've got to understand that CO2, while it behaves like other refrigerants, it also does some strange and peculiar things when you start getting around the critical point where it starts changing from a subcritical to a supercritical fluid, it's unstable and it requires some understanding. And that's probably the biggest challenge with transcritical, is getting people to understand that, yes, it does some strange things, but ultimately it does the same thing as everything else as well. Is that a reasonable answer for you? Please.
I was 24 years old in 1964 when ship pulled up at where the Opera House is now, the top end of Macquarie Street. Gives you some idea of my age. Anyway, what I want to say is this. I've been designing evaporator condensers since 1966. And when I said I need one for CO2, and they were for ammonia, by the way, they're quite simple. When I needed one for CO2, I couldn't do it. I could not do it because of what Ian just said. Everything changes around a critical point. The specific heat changes, right? The conductivity changes, the viscosity changes, all important parameters in heat transfer. So I engaged a scientist to help me out, and he was the former dean, retired dean of the Faculty of Engineering of Royal Melbourne Institute of Technology University, and he couldn't do it either. After 6 months he had his epiphany, he stayed on the road to Damascus, had his epiphany, and he said, I can do it. $40,000 later, we have now world-leading science, and we have applied for patents. I'm not only a consultant who should change his aftershave coming to meetings like you, but I mean. Sorry, beg your pardon. So, yes, I have that interest. And in fact, it's interesting, you're from HVACR. One of your senior people in the United States is Frank, is it? Frank in Maryland? Yeah. Frank asked me this. I asked Frank at the meeting, a AAR meeting in America one day. I said, Frank, do you have a CO2 condenser? He said, no, who would be bothered? But believe me, it's the future. Thank you very much.